So what is a transformation? If you have a vector space X and another vector space Y, then transformation is a rule which assigns to each vector in this space another vector in this space. So transformation is a rule which assigns to each vector in this space another vector in this space. This transformation is generally denoted by FRT, f of x, or sometimes it is also denoted by t of x. This transformation is a linear transformation if it satisfies two conditions, that is the superposition and homogeneity. And if this space X is Rn and this space Y is Rm, then the transformation can be described by a matrix. That matrix, what will be the dimension of that matrix? In this case, this transformation, if X is Rn and Y is Rm, this transformation can be described by a transformation matrix. This transformation matrix is also called standard matrix of that transformation. And what is dimension of this matrix, size of this matrix? M by n. And you can verify that this is a linear transformation. We take a few examples, a few more examples to demonstrate the concept. We want to find a transformation matrix that will rotate a vector in this two-dimensional space R2 by an angle of phi. So how we can find that transformation matrix? So that is, let's take this vector, and this transformation will rotate it by an angle phi. So how to find that transformation? That is, if we name this vector as, you can give it any name, let's say E1. E1 is this vector, and then operated by this transformation generates another vector Y1. And you can see that this vector E1, what is that vector? It is 1, 0, and this vector Y is cosine of phi and sine of phi. So t of E1, t into E1, whatever notation you like. How it is that? So this vector, transformed vector, what is its this horizontal component, cosine of phi, and vertical component, sine of phi. And let's consider another vector E2. Then E2 is, let's say, this vector. What will be the effect of this transformation? It will rotate it by an angle phi. This angle is phi. So what is this Y2? So Y2 is equal to, what is this component? What is this component? Yes? This one, cos of phi. This is cos of phi. And what is this component? This length is sine of phi. Since it is negative, so minus sine of phi. This is minus sine of phi. This length is the same as this length. which is sine of phi. So the transformation matrix is given by, sorry, can you, what do we mean? If we have, for example, this vector, so this transformation will rotate this vector by an angle of phi. Let's verify whether this transformation rotates it. Let's take some particular angle which is convenient, for example, phi equal to 45 degrees. And let's see whether this transformation will rotate this vector by an angle of 45 degrees or not. So let's see that. What is this vector? So this transformation y is equal to t into, let's call this vector x, and t, you know, we have already found that cosine of phi. What is cosine of 45 degrees? Cosine of 45 degrees and sine of 45 degrees, here is minus sine of 45 degrees and cosine of 45 degrees multiplied by x. X in this case is minus 1 and 0. So we get this vector, this multiplied by this, minus cosine of 45 degrees and then sine of 45 degrees. What is numerical value? Minus sine of 45 degrees, you are right. So minus sine of 45 degrees. What is cosine of 45? Minus 0.7, 0.707, and sine of 45, that is also the same. So where is this vector? Minus 7.07. So this vector has been rotated by that particular angle. So there is a small mistake, please correct it. Here it only produces rotation, so length must be the same. This is good observation. And this vector has been rotated to this position, not to this one. What is an onto transformation? Again, you have two vector spaces, x and y. These are vector spaces. If every vector in this space is an image of a vector in this space, then this transformation is called onto transformation. So this transformation T, which maps a vector in Rn to a vector Rm, this transformation will be called onto transformation or onto mapping if for each vector each vector in this space is an image of a vector in this space. Let's elaborate it with the help of an example. We have this transformation. So what does this transformation do? The transformation matrix, the standard matrix, is given by this matrix. So what does this transformation do? This transformation maps a vector in R from an R3 into R2, right? So is this transformation an onto transformation? So if any vector in this space is an image of a vector in this space, then it means that we can always find solution to this system of equation. In this particular case, is it always possible to find the solution to this system of equation for any y, any vector in this space? So how you are finding the solution to this system of equations? You are constructing augmented matrix to find the solution x, this is similar to this system of equation which you have already studied. Ax is equal to b. It is the same form. So how you are solving this system of equation? You are constructing augmented matrix, in this case, and the right hand side. So this from here we can see that for any y1 and y2, any value of y1 and y2, solution always exists. That is, for any y1 and y2, we can find this vector. That means any vector in this space is an image of a vector in this space. Therefore, this transformation is an onto transformation. What about this transformation? This transformation maps a vector from R2 into a vector in R3. So is this transformation an onto transformation? Why no? So uniqueness is not required, but your answer is correct that this is not an onto transformation. Why? Because to find the solution to this system of equations, we construct augmented matrices. So this is the augmented matrix. Can we always find a solution to this system of equation? So it can be easily reduced into echelon form, and we can see that solution will not always exist. Solution will not always exist. So it means that there are certain vectors in this space which are not images of vectors in this space. Therefore, this transformation is not an onto transformation. What about, for example, this transformation? What about this transformation? So is it an onto transformation? No, it is not an onto transformation. Why? There exists some vector, you know the procedure, how we were, there is no third row basically, no third row over here. Otherwise this equation is not correct. So to find the solution to this system of equations, you construct augmented matrix and determine if there always exists a solution to this system of equation for any arbitrary values of y1 and y2. So no, solution does not exist. For some values, solution do exist, but for other values, it does not exist. Therefore, this transformation is not an onto transformation. Any confusion or question regarding this discussion? Ji. For example, if I have this vector 1, 1 in this space, this is a vector, so corresponding to this vector, can you find a vector in this space for this transformation? Can you find it? So here, to solve this system of equation, you will write here 1 and 1. So 0 is equal to 1, solution does not exist. That means corresponding to this vector, there is no vector in this space. Therefore, this transformation is not an onto transformation. Here, you can, if you have any value of y and y2, you will be able to find corresponding values of this vector x. So therefore, this transformation was an onto transformation. No, not necessarily. Inverse transformation की अभी हम बात करते हैं. तो फिर इस क्वेश्चन को भी एड्रेस कर लेते हैं. But before we talk about inverse transformation, let's talk about another transformation which is called one-to-one transformation. So it is quite possible for for transformations, it is quite possible that multiple vectors in this space, this is space X and here this is space Y, and the transformation, this is a transformation which maps a vector in space X into a vector into space Y. So this is quite possible that multiple vectors in this space map to a single vector in the other space. That is quite possible for transformations. Can you give some examples? For example, if we have this transformation, then this vector, where does it map? Here the third component as well. Where does it map? This 1 and 0. So this vector, which belongs to space X, is mapped over here. What about this vector? Where is it mapped? So 1 multiplied by 1 is 1, so 0. So it is also mapped to the same vector. So it is quite possible that multiple vectors in this space are mapped over here to a single vector. However, if corresponding to each vector in this space is mapped to a unique vector in this space, then this transformation is called one-to-one transformation or one-to-one mapping. I write the statement. So here is a transformation which maps a vector in Rn into a vector in Rm. So this transformation will be called one-to-one transformation if each y is an image of at most one vector in this space. This vector is an image of at most one vector in the space X, vector space X. Then this transformation is called a one-to-one transformation, one-to-one mapping, one-to-one transformation. For example, what about this transformation? Is it a one-to-one transformation? No, because each vector is an image of multiple vectors. So this transformation is not a one-to-one transformation. So here is a transformation which maps a vector from R4 into a vector in R3. So what about this transformation? So solution is not unique. Solution is not unique. Therefore, this is not a one-to-one transformation. Yes, there is a question. So the question is, we have, for example, here X is R2 and Y is R3, and for each vector in this space, it is an image of at most one vector from this space. Then this transformation will be one-to-one transformation. Example. So what about this transformation? Is it a one-to-one transformation or not? So if either there exists no solution or there exists only one solution, unique solution, right? Either, for example, how to find the solution to this system of equation? Again, construct the augmented matrix. That augmented matrix is given by this thing. y1, y2, y3. So you can see that, easily see that if y3 is not equal to 0, then there is no solution. If y3 is not equal to 0, then there is no solution to system of equations. However, if y3 is equal to 0, then what is the case? There is unique solution. What does that mean? There are vectors in this space which have no, which are not image of any vector in this space, and there are some other vectors in this space which are image of only one vector in this space. So here this word at most one vector. So some vectors may not be image of any other vector, any vector in space X. So what is this transformation? This transformation is one-to-one transformation. Why? Because vectors in this space are images of at most one vector in this space. So at most is, that is also important to know. If there are vectors which are images of multiple vectors, then that transformation will not be one-to-one transformation. So the question is it a transformation? So transformation is a rule which assigns to each vector in this space another vector in this space. So that is satisfied for this case. Can you find any vector x for which there is no corresponding vector in this space? Can you tell any x for which there is no vector in this space? You cannot find that vector. So take any value of x, you will get a value of y. So transformation is a rule which assigns to each vector in this space another vector in this space. So this is definitely a transformation. So is it a one-to-one transformation? Yes, it is one-to-one transformation. Is it an onto transformation? Is it an onto transformation? What was definition of onto transformation? Each vector here is an image of a vector in this space, then this transformation is called onto transformation. So that is not true for this transformation. So this is not an onto transformation. This is one-to-one but not onto transformation. There was some question from, yes, y1 here, y2, y2, and here 0, 0, second row 0, 0. So first question, is it a transformation or not? This is first question. So what do you think? Corresponding to any vector here, can you find a vector over here? Why not? Can you tell me any vector here corresponding to which you cannot find this vector? For example, can you give any example? So this multiplication can always be performed. Take any value of this thing. So this will be simply x1, 0. So corresponding to any value of this x, you are able to find value of this y. That is corresponding to any vector in this space, there exists an image. So transformation, which is a rule, has assigned a vector to this transformation. Now the question is it an onto transformation? Is it an onto transformation? Under what condition it will be an onto transformation? If any vector in this space is an image of a vector in this space, then this transformation is onto transformation. So here, what about this transformation? There are some vectors in this space which are not images of any vector in this space. For example, this vector is not image of any vector. This vector is not image of any vector. So this transformation is not onto transformation. So is it one-to-one transformation or not? If solution exists, that will always be unique. Either no solution exists, or if it exists, then that is unique. So this transformation is one-to-one transformation.